Okay, let's look at the homework 5.2, 5.3, problem number 9. All right, so we want to solve this following linear programming problem. So we want to maximize this objective function, p equals 2x plus 2y, right? And here's the problem constraints and also non-negative constraint, right? Let's first sketch the feasible region. Right. Alright, so let's sketch the feasible region here. So, alright, so first we're gonna turn this into a equality. So here, this is going to be 2x plus y is equal to 10. Right? Then we can actually find x-intercepts and the y-intercept from here. So this guy has x-intercept is going to be, alright, so put y equals 0, 2x equals 10, so it's got to be 5, right? And how about the y-intercept? Right, y-intercept is going to be, put 0 here, y equals 10, so we have that. Right, let's do the same thing with the second inequality. So turn that into equality. So you have x equals 2y is equal to 8. Right? From there, we can easily find x-intercept is going to be, put 0 here, 8. And the y-intercept is going to be, right, 2y equals 8, it's 4. Right? So let's sketch the picture. So first we have x-axis right here, right? Oh, actually, I want to make it a little bit longer. All right, so x-axis, and here's our y-axis. All right, so just draw that, and that's 0 right there. All right, so first one, x-intercept is 5, so it's going to be, I'll probably put 5 over here. All right, then y-intercept is 10, so it's double that, it's probably up here. So this is going to be 5 right in the middle, so this is 10. Right, so the borderline for the first inequality has to go through these 2 points, right? So I'm gonna just draw a line through both of them, so it's gonna look something like that, right? Sorry, I missed it. So something like that. All right. For the second one, y-intercept is 4, so this is 5, so it's going to be slightly lower than that, so it has to go through 4 here. All right, and x-intercept is 8, so that's going to be 10 here, so it's probably 8 is around here. All right, then connect those 2 dots together with a straight line. All right, it's not a very good job, but you have that. All right, good enough. All right, then we also have to choose the correct sides. So for this one, for the first one, I'm gonna just look at 0, 0, plug in 0, 0 into the first inequality. 0, 2, 0 times 0 plus 0 is 0 anyway, is less than or equal to 10. So we have to pick the half plane that contains origin in it. All right, same deal. 0 plus 2 times 0 is certainly less than 8, so we have to pick the half plane that contains 0, so which is lower half plane. All right, non-negative constraint is easy. It's basically telling you that it's going to be the first quadrant, so it's going to be above the x-axis and to the right of the y-axis. So we can see that this is the feasible region. All right, so we have a feasible region. All right, let's find all corner points. So here's our corner points, right? Right, then we want to probably list the corresponding p-value, so p. So let's make a table. All right, so we're gonna make a table like that. All right, so you have a corner points. All right, so then you have, let's see, there will be 4 corner points, so I need 4 slots. Let's see, so this, all right. All right, let's fill them in. All right, so easy one would be the origin. So 0, 0 is one of the corner point. All right, also a 5, 0 is another corner point, which is this one. And or 0, 4 is another corner point. All right, the last corner point, we have to actually do a little bit of work here. This is an intersection of these two equality, these two borderlines. So we just have to find a common solution. All right, so I would probably multiply the top equation by 2. So you would get, I'll probably do it here. So 4x plus 2y is equal to 20, right? Then bottom equation, I'll keep it just exactly as it was. X and 2y is equal to 8, right? So do the subtraction, just like before. 4x minus x is 3x. And 2y minus 2y is 0. And 20 minus 8 is 12, right? So this would give you, divide through by 3, x equals 4, right? So once you know that x equals 4, you can just plug it into either equation. I'll plug it into the top equation. So 2 times 4 is 8, plus y is equal to 10. So this will give you y equals, just subtract the 8 from both sides. 10 minus 8 is 2, right? So this point right here has a coordinate, x equals 4 and y equals 2. So it is 4, 2. All right. Then we're going to compute the corresponding p-value for each corner point. All right, 0, 0 is easier. You plug in 0 here, so it's going to be 0. So p-value is 0. And if you plug in 5, 0, so 2 times 5 is 10, plus 2 times 0 is 10, plus 0 would be 10. So p-value is 10. All right, 0, 4 is, let's see, 2 times 0 plus 2 times 4 is 8. So we have 8. And 4, 2 would be 2 times 4 is 8, plus 2 times 2 is 4. So 8 plus 4 would be 12. All right. So since we are trying to maximize the p-value, you can see that the 12 is the maximum value, and which occurs at the 4, 2. Right? So let's go back to the problem. Right? P is 12. So type in 12. Then see if answer is correct. Check your answer. Yep. So that's that. All right. Second part. So it says select the correct choice below, fill in any answer. All right, so the coordinates are, all right, so we're looking for what are the coordinates of the corner point where maximum value P occurs. All right, go back to the picture. It was 4, 2. So let's type in 4, 2. All right, so coordinates are, all right, this is going to be 4, whoops. Let's see, coordinates are 4, 2. All right, let's check. All right, got it. So click on that. All right, that's it. I hope that this was clear.